perfectly inelastic collision, we consider that we have two particles, m1 and m2. The velocity of particle 1 is v1 and velocity of particle 2 is v2. v1 is greater than v2, what means that at some time the collision happens. And because we assume that this process of collision is perfectly inelastic, it means that both particles will match together at one particle finally with mass m1 and m2 and with unknown velocity v star. Okay, so this is a new system. So this is a system of particles. It's a system of particles before collision, and this is a system of particles after collision. And our task is to calculate final velocity. If we know m1, m2, v1, v2, so task is what is v star. So let's make a short analysis. There we can't see any external force. There is no external force. All forces acting here during inelastic collision are internal forces. So we can say from the previous denomination that this sum of external forces is equal to 0. And if we use a law of change of momentum, P2 minus P1 is equal integral Fe dt from time 1 to time 2. So if there is no external resulting force, so this is equal to 0. From this we can say that P2 minus P1 is equal to 0, and we transformed law of change of momentum of system of particles into law of conservation of momentum. We can rewrite this law into scalar form. If we consider that x is supposed in this direction, horizontal direction, so we can write that p2x minus p1x is equal to 0. So this is before collision, momentum before collision, and this is momentum after collision. So we can write that momentum of the system of particles before collision is p1x. And as we know, the total momentum of the system of particles is given by sum of individual momentums of individual particles. So it is m1 v1 plus m2 v2. And what is the momentum of the system of particles after collision? So it is p2x, and in fact we have only one particle of mass m1 and 2, and of velocity v star. And we can substitute into this star equation, okay, substitution into star equation. So we can write that m1 v1 plus m2 v2 is equal m1 plus m2 by v star, and from that v star is m1 v1 plus m2 v2 over m1 plus m2. So this is velocity of particle m1 plus m2 after collision. Let's calculate now the difference of kinetic energy of system before and after collision. So kinetic energy before collision is K1 is equal a half of m1 v1 square plus a half of m2 v2 square. Kinetic energy of the system after collision is K2 is equal to 1/2 of m1 plus m2 by v star square. When we calculate the difference of energies, K2 minus K1, so we can do it by substituting from this. So we can expand this, it is m1 plus m2 by the previous result is m1 v1 plus m2 v2 over m1 plus m2 powered by 2. So immediately we can cancel this. So I can put out of the brackets 1/2 because it is everywhere, and I can substitute this m1 plus m2, and there is m1 v1 square plus 2 m1 v1 by m2 v2 plus m2 square v2 square. So it is k2 minus k1 minus, and I will expand it by this denominator. So in denominator there remains m1 by m1 plus m2 by v1 square plus m2 by m1 plus m2 by v2 square, end of brackets. So it is equal 1/2 of m1 plus m2, because there is the same denominator of these terms, and we can rewrite this denominator, this one, minus m1 square v1 square minus m1 m2 v1 square minus m1 m2 v2 square minus m2 v2 square. And we can see that we can cancel something. So we see this, and we can cancel it, oh sorry, there is by, with this. There is also this term, and we can cancel it with this term. And what remains here is this term, so I can put out the minus sign, and there remains this and this. So it's m1 m2 by v1 square. That is this also, so it is minus 2 m1 v1 m2 v2 plus what remains here, m1 m2 v2 square. We can put out the brackets multiplication of m1 m2 because it contains every term like this, and what remains we can write in this form. So finally we got that a difference of energy after collision and before collision is negative, so we lose energy during collision. The system before collision has a lower kinetic energy than after collision. And what happened with this amount of energy, where this energy disappeared? This energy was used to reshaping the system of particles, because originally we had two individual particles, and here, because it's ideally inelastic, it means ideally plastic. So both particles changed, transformed to one big particle, and this change needed some force action, and these force were working force. This force made some mechanical work. So the difference is equal to the work of working forces, so that there is no applicable the law of conservation of mechanical energy, because K2 is not equal K1, but there is applicable the law of change of kinetic energy.